All right. Next up, we have John Todd with INOC DBA for the rest of the world.
Hi. Actually, the project is freenum.org, and the subtitle is that INOC DBA, for those of you who aren't familiar with it, we're kind of taking some lessons learned from prior IP or voice over IP interconnections between ASN holders and applying them to a much larger scale. So real briefly, what the problem is right now with some voice over IP technologies is that many of them are using SIP URIs, or what look like email addresses, and we're trying to communicate with devices that have a 12-digit keypad, an old phone, DTMF. In order for people with DTMF keypads, which is 96 or 98% of the world, to communicate with people who have IP-based platforms, we've kind of got a problem. We've got these URLs which are alphanumeric versus the only ability to enter things in with keypads. Now, INOC DBA, as many of you are aware, I'm going to plug them for a second because it's a really interesting service. They solve the problem for ASN holders by basically creating a dialed, this slide looks terrible with they make a numeric-based dialing system using ASNs as part of a new dialing sequence, basically embedding the ASN as part of a phone number as an overlay, a private voice over IP peering network. That uses a central SIP proxy and is really good for its purpose. Everyone registers to the central SIP proxy. If you're an ASN holder and you'd like to have inter-NOC communication, I would strongly suggest you take a look at the pch.net site and sign up if you haven't already. The problem, however, with that is that INOC DBA is only available to organizations who have an ASN. They create dial strings something like 11893 star 123, where the first part of that on the left-hand side of the star is the ASN, and on the right-hand side are the initials of the person you're trying to reach. And the star in the middle, which is available on a DTMF keypad, kind of supplants the @ sign. So we go from least specific portion, which is the ASN, to a star, to the most specific portion, which is the extension, if you will, of the person you're trying to reach. As far as other VoIP peering methods that use IP, we've got some problems with using telephone numbers, meaning the numbers you're all familiar with are called E164 numbers, and they are tied to legacy issues. Notably, there's taxation issues, there are monitoring issues, there are use issues. Most nations have PTTs or some other organization that regulates E164 numbers. So giving everyone with an email address an E164 number as an overlay also has some problems because it doesn't scale particularly well, and in some places it's completely impossible. Also, when you're looking at E164 numbers, you can't delegate them. They come in, while it looks like hierarchical models, really the only hierarchy is typically geography and subgeography. Two numbers with two different people are going to be going to two completely different places, so you have to have a completely atomic distribution of your routes. Unlike route aggregation, most numbers are going to be ending up in different places, especially when you're looking at non-enterprise. And then lastly, E164 has some real problems with ownership. Who owns your phone number? Meaning, if you're going to use your phone number as an identifier for voice over IP transactions, who actually owns it? Do you own it? Does your company own it if you're getting a number from your company, or does the phone company that you're getting that own it? So you've got 3 or 4, in some cases, different layers of ownership, which is very problematic and doesn't map particularly well to the way that Internet Protocol addressing works or pointers work. So I'm going to go right to what freenum.org proposes, and that is we're proposing a slightly different method of creating a new numbering system that anybody has available to them for free. This is an example of what a freenum.org ISN looks like, 1234 star 256. We've taken the INOC DBA model and we've changed it slightly. So now the 1234 in this number is actually the extension of the person you're trying to reach. This is the user portion of an ISN. The star, again, replaces the @ sign, but then 256 in this example is what's called an ITAD number. What an ITAD number is that it is an allocation that IANA has from RFC, and this is a typo here, RFC 3219, which described a BGP-like protocol for telephony. IANA has allocated 850 of them, or 852 as of yesterday. It's a 32-bit number, so more than 4 billion potential numbers allocated. So I think there's plenty to go around for all the organizations in the world right now, which is a problem we've had with other protocols. And they're free. Simply sign up for an ITAD and your organization will get one, and you can start using this immediately. So how does freenum.org work? Meaning when you dial one of these numbers on your phone, whatever SIP-based PBX platform you have, or even TDM-based platform, what actually happens? We're using the DNS in this model to distribute all of the information as far as NAPTR records. You can delegate, and an organization can have all of control for all of their numbers delegated to them, removing kind of that authority problem with traditional telephone numbers. The DNS lookup occurs with what's called an NAPTR record, and a SIP URI is returned, and your phone system typically will understand how to deal with a SIP URI if it's voice over IP capable. We also embed in DNS for every one of the organizations. We embed the name of the organization, and if you would like, you can embed time zone, language spoken, etc., into the DNS so that people doing number lookups on you or receiving calls from you can look that up and display it in whatever way they'd like. So here's a quick DNS detail as far as what happens when you dial one of these numbers. So 1234 *256, we use the standard enum-based reverse lookup protocol only on the user portion. So we reverse the user or the extension portion and put dots in between it. And then we use the ITAD number, which is again equivalent to the domain name for an organization or the domain registered number for the organization, and make that a zone, and then add freenum.org at the end. When you do that type of a lookup with an NAPTR, you end up with a SIP URI, in this case 1234@lalago.com, which dials a phone, rings the extension 1234 at that SIP PBX. So isn't this like enum? Well, yes and no. It uses most of the same protocols. In fact, it uses exactly the same protocols for all of the lookups. The difference is that the zone that you're looking things up in is actually delegated out, and there's a new numbering system for allocation that can be delegated to the individual company so they have control on their own. It scales as far as the DNS will scale, so far I'd say that test is working out pretty well. And does it solve SPIT or spam over telephony, internet telephony? And the answer is no, it doesn't. It's simply a pointer system which allows you to determine what PBX or what device is going to receive a call. It doesn't describe whether that device is going to accept the call or not, and that's an orthogonal issue to the pointer. We have currently about 600 participants. We've been running the tests for about 2 years. We're now out of test. We're in actual production. We put up self-administration web pages, so now the process from soup to nuts of getting an ITAD, registering at the freenum.org DNS is almost completely automated except for one approval by a person to get your number entered. We have a large base right now in the higher education community and in what I'll call next generation service providers who are providing telephony service to their users. We even have a GSM provider who now says that they've got it so that you can dial these numbers from the mobile SIMs that they're providing to their customers, and we anticipate seeing many more of that type of platform. And there's an extensive interest in North America is about half of our user base, but the other half is not North America. It's all over the place. I think we have something like 46 or 48 different nations right now where this test is active, or where these numbers are active and who are using the freenum.org dialing system. It's an easy 4-step process. Everything is free and almost completely automated. You take a look at the freenum.org site for instructions on how to get an ITAD from IANA. You go to the freenum.org site after it's allocated to you, and you put your DNS records in place. And then if you want, which is probably the best way to do it, you would allow your PBX or your SIP proxy to actually start dialing or reaching these numbers. We have these different platforms are able to use the freenum.org dialing system. They're able to receive and make calls. Even the dumbest, most brain-dead SIP platform can actually use our system. We have gateways available if you don't have particularly good scripting capability on your platform. We have, I think, 3 or 4 different ways where your system can gateway a call into or out of the freenum.org system if it cannot do it natively. So pretty much any SIP platform will work, and this is basically a list of the ones that have been tested. And that's the end of the show. I'm available, or slideshow, I'm available for questions after this, or you can email me at jtodd@freenum.org. Thank you.
Any questions?